Hello everyone, welcome back to Shree Radhe Studies. In this chapter, we are going to study informed search techniques, one of the most important concepts in artificial intelligence. In previous chapters, we learned about search techniques that explored paths without having any prior knowledge. But in real life, intelligent systems cannot afford to waste time exploring every possible path. Instead, they use additional information to make smarter decisions. This additional information is called heuristics. In this chapter, we will understand how AI uses intelligent guessing to quickly reach its destination. We will study heuristic search, greedy-based first search, A-star search, and their real-world applications in GPS navigation, robotics, video games, and autonomous systems. By the end of this chapter, you will clearly understand how modern AI systems make faster and smarter decisions. Imagine you are trying to reach a destination in a new city. One option is to explore every road one by one until you finally reach your destination. Obviously, this approach is extremely slow and inefficient. Instead, we use Google Maps, which intelligently suggests the shortest path. This is exactly why informed search was developed. Uninformed search blindly explores every possibility, whereas informed search uses extra knowledge called heuristics to guide the search process. This provides four major benefits. First, it makes the search faster. Second, it makes smarter decisions. Third, it reduces computational effort by avoiding unnecessary paths. Finally, it produces better results with less resource consumption. In simple words, informed search can be remembered as knowledge plus search equals faster solutions. Now, let us understand the most important term of this chapter, which is heuristic. A heuristic is simply an intelligent guess. Instead of calculating every possibility, AI estimates how close it is to the destination. This estimated value is represented by h of n. We can think of heuristics as the common sense of artificial intelligence. For example, Google Maps estimates the shortest route before we start traveling. Video game characters predict the best possible move. Robots estimate efficient paths before moving. Even puzzle-solving systems use heuristics to place pieces correctly. So heuristics do not guarantee perfection, but they significantly reduce time and computational cost by providing good estimations. Informed search has 5 important characteristics. The first characteristic is the heuristic function h of n, which estimates the distance to the goal. The second characteristic is efficiency, because only promising paths are explored. Third is faster execution, because unnecessary computations are avoided. Fourth, informed search can be optimal if a good heuristic is used. Finally, it can be complete, meaning it can guarantee finding a solution if one exists. There is one simple rule that students must always remember. Good heuristic means good performance. The quality of the heuristic function directly determines how intelligent and efficient the search algorithm will become. There are 4 popular informed search algorithms that every AI student must know. The first one is greedy-based first search. It always selects the node that appears closest to the goal by using only heuristic values. The second algorithm is A-star search. It combines actual cost and estimated cost to provide optimal solutions. The third algorithm is idea star, which is a memory-efficient version of A-star and is suitable for large search spaces. Finally, beam search keeps only the best nodes at each level to reduce computational load. To easily remember these algorithms, use the memory trick GAIB, which stands for greedy, A-star, idea star, and beam search. Now let us understand how heuristic search actually works. Instead of checking every possible path, AI intelligently estimates which direction appears most promising. There are 5 main components involved in this process. First is the state space, which represents all possible configurations. Second is the start state, where the search begins. Third is the goal state, which is the final destination. Fourth is the successor function, which generates neighboring states. Finally, the heuristic function estimates how close we are to the goal. The process follows a simple sequence. Start the search, explore neighboring nodes, estimate their values, choose the best option, and continue until the goal is reached. This strategy dramatically reduces search time. Greedy-based first search is one of the simplest informed search algorithms. It always chooses the node that appears closest to the goal. The algorithm only uses h of n and ignores the actual distance already traveled. The process starts from the initial node. Then it evaluates all neighboring nodes After that, it selects the node with the smallest heuristic value and repeats the process until the goal is reached. This approach is extremely fast and simple. However, it has limitations. It may get stuck in local optima, it does not always find the shortest path, and its performance depends heavily on the quality of the heuristic function. A-star search is considered one of the most powerful search algorithms in artificial intelligence. It combines the advantages of greedy search and uniform cost search. A-star uses three functions. G of n represents the actual cost from the starting node. H of n represents the estimated cost to reach the goal. F of n is calculated by adding both values together. The formula is f of n equals g of n plus h of n. During execution, A-star always selects the node with the smallest f value. If the heuristic is admissible, meaning it never overestimates the true cost, A-star guarantees an optimal solution. This is why A-star is widely used in GPS systems, robotics, and modern AI applications. There are two commonly used heuristic distance measures. The first one is Manhattan distance. It calculates the total horizontal and vertical movement required to reach the destination. It is widely used in grid-based games and city maps. The second one is Euclidean distance, which calculates the straight line distance between 2 points. It is commonly used in GPS systems and robotics. Now let us compare greedy search and A-star search. Both algorithms use heuristic values. However, greedy search only uses h of n, whereas A-star uses both g of n and h of n. Greedy search is faster and uses less memory, but it does not guarantee optimal solutions. A-star may use more memory, but it produces reliable and optimal results. Let us conclude this chapter by looking at real-world applications. GPS navigation systems use informed search to find the fastest routes. Robots use it to plan efficient movement paths. Video game characters use it to make intelligent decisions. Logistics and scheduling systems use it to optimize resource allocation and delivery routes. Before ending this chapter, remember three important points. First, heuristics are intelligent guesses that estimate the cost to reach the goal. Second, greedy search uses only h of n, making it fast but not always optimal. Third, A-star uses both g of n and h of n, making it one of the most reliable algorithms in artificial intelligence. Understanding these concepts is extremely important because they form the foundation of many modern intelligent systems.